Welcome, guys. Welcome back, guys. This is the very last day of week 6. Today is May 6th, 2022. Remember to place the date at the very top and leave the empty space for the topic name, which we will be adding not today, but in our next class. Okay, so we're going to continue multiplying binomials just as we were multiplying binomials. Now, before we begin with that multiplication of binomials, I just want you to remind yourself, okay, Valeria, that if we have x times x, that is the same thing as saying x to the square. And the other way around, if we have y to the square, it is the same thing as saying y times y. So the same thing times the same thing is that thing to the square. Or if we have one thing to the square, it is the same thing as saying that multiplied twice. So if I say x plus 2 times x plus 2, it is exactly the same thing as saying x plus 2 to the square, okay? So we know that if we have x plus 2 times x plus 2, according to what we saw last week, this is going to be solved using FOIL, right? That is like the easiest way to use FOIL to multiply the first term of the first parenthesis times everything inside the second parenthesis, okay? That is the easiest way of solving that. Well, we're not wanting to do it that way because there is actually an easier way to solve it when we have exactly the same thing multiplied by itself, or if we have it to the square. It is easier to do it with that other method that I'm going to show you, okay? So taking this into account, that x plus 2 times x plus 2 is x plus 2 to the square. If we have a monomial, adding another monomial, like this case, okay, remember monomial could be a variable, could be just a constant, it could be the multiplication between a variable and a real number, and the variable might also have exponents. So monomial could be that. So we have a monomial plus another monomial, and that is to the square or multiplied twice. The easiest thing is to use this formulas, this special situation formulas for multiplications of binomials. This applies only for multiplication of binomials, okay? So we are going to say, identifying what is A, the first monomial, and B, the second monomial. We're going to say the first monomial to the square plus, because this is an addition, 2 times the first monomial times the second monomial plus the second monomial to the square. And if it is a subtraction, it is basically the same thing, except that instead of an addition, we have a subtraction in between our first and second term, okay? So these two formulas are called perfect squares, okay? These formulas are for perfect squares, and I want you to have those formulas in an index card, not in your notebook, not in a white page, but in an index card or a piece of cardboard or construction paper, just like we have done several times before, okay? Index card. So I want those two formulas, and then you place the name of those formulas, which is perfect squares. This is the sum of a perfect square, and this is the subtraction of a perfect square. If we solve it with the formula or we solve it with FOIL, we should get exactly the same answer. So right now, I'm going to solve it using the formula because I have x plus 2 to the square. Okay, so the first thing that you're going to do is identify monomial A and identify monomial B. Okay, that's the very first thing. So monomial A will always be from the middle sign, the addition or the subtraction, all the way to the left. Monomial B is going to be from the sign to the right. We don't take into account the sign. As you can see, if it is a sum, both of them are additions. If it is a difference, the first one is a subtraction. The second one is still an addition. So this sign is applied over here. So I don't need to take into account the negative sign, okay? Just the term itself, just the monomial itself, okay? This is the only case. So taking that into account, this will be A because it is from the sign to the left. And from the sign to the right, we identify it as B. And we're gonna use what formula? Formula 1 or formula 2?
The one.
Formula 1, because it is an addition. Very good. So I'm gonna copy this part of my formula, copying it here, and I'm going to start substituting the values of A and the values of B that I just identified. So I'm going to say A to the square. A is X. So X to the square plus 2 times, I'm going to place this 2 in black because it's part of the formula, A, that is X, and B, that I identified as 2, plus B to the square, and B is 2. So 2 to the square. Now I simplify that, I solve that, and I have X to the square. How much is that? X squared, right? Now, as you can see, I have a multiplication between 2x and 2. So I multiply the numbers, 2 times 2, 4, and I multiply it times x, so 4x. Plus, how much is 2 to the square? How much is 2 to the square?
4.
4, very good. And that is my final answer. And that is using the formula. Okay, now I'm going to solve it, same exercise, but I'm going to solve it using FOIL. I'm going to do it in green. And since we know that if this is to the square, it is the same thing as writing the parentheses twice, then I can solve it using FOIL. The first term of the first parenthesis times everything inside the second parenthesis, and the second term of the first parenthesis times everything inside the second parenthesis. So x times x, x to the square, right? X times 2.
2x.
For the second term, 2 times x.
2x.
2 times 2.
4.
Now we know that every single time that we have binomials that have exactly the same exponent, the middle terms are like terms. So I'm going to simplify that, and I get x to the square. How much is 2x plus 2x?
4x.
So plus 4x plus 4. And that is the same answer. You can see we have exactly the same answer. Either if we do it with the formulas for this special cases, or if we use FOIL method, we get exactly the same answer. So you're going to solve it according to your instructions, according to the given instructions, okay? If I say solve the following exercises using the formulas, then you use the formulas. If I say use FOIL, then you use the distortive property that's called FOIL for these specific cases, okay? So depending on the way that I say, if I only say simplify, you use whichever method you want. Okay, we clear? Okie dokie then. Let's go with the next exercise, which is this one over here. In this case, you can see now my variable has a coefficient. In this case, it's coefficient 2. 2v minus 3 to the square. Since we're learning the formulas, we're going to solve it with the formulas. So what formula should I use? Formula 1 or formula 2?
Formula 2.
Formula 2. So I'm going to copy my formula 2. Oops. Okay, I'm going to copy my formula 2. Copy it over here. And I'm going to identify A and B. Okay. What would be A in this exercise? What would be A in that exercise?
2b.
B, exactly, that's A. Because it is everything to the left. And B, what would be B?
-2.
3.
3, only the 3 without the sign, very good. Why? Because the sign is already applied in the formula, it's already there. So now I just go ahead and substitute. So instead of A, it will be the whole 2V. So 2V to the square minus the 2 of the formula times A, which we said already it is 2V, times B. And B, we said it was 3 without the sign, right? Because the sign is already there. Plus 3 to the square, because 3 is B, and B should be to the square. Now we go ahead and simplify that. How much is, what are we doing here? 2V to the square, we're doing power of a power, where we are going to affect with that square, not just the variable, but also the coefficient. So how much is 2 to the square?
4.
4B.
4V to the what?
To the second power.
Power to the square. Very good. Don't forget the sign. Okay, minus, copy in the minus. We go ahead and multiply the coefficients. In this case, 2 times 2
4.
times 3. 4 times 3,
12.
12.
12. And I copy my variable, 12V. Plus, how much is 3 to the square?
9.
9. And that is my final answer. It is easy, right? It's easy to solve using the formulas. Questions so far? Okie dokie then. Now we're gonna do another one which becomes a little bit more complex, okay? A little bit more complex. And in this case, we got, why is it complex? Because variables have exponents and they have coefficients. And we have 2 variables, not just one. We got 2 variables. Okay, so that's why it's more complex. Actually, you can have the whole alphabet if you want, and you're gonna do exactly the same thing, okay? So step 1, identify what formula we're using. Formula 1 or formula 2. Formula 1 or
Formula 2.
formula 2 as well. So it is as well as subtraction. So I'm going to copy my formula over here, and I'm going to identify now A and B. Okay, what is A?
2x to the
3x
second power.
to the power.
Exactly, all of this is A. 2x to the second power, that would be A. What would be B? What is B? What is B in there?
2y to the power.
2y to the third power without the sign, right? Because the sign is already in the formula. Okay, so we just go ahead and substitute now. Instead of A, I'm using 3x to the square, and that should go to the square. You see, this square is this one outside. This that's inside is what A stands for. Okay. Now I go with the next one. And the next one is minus this 2. I'm going to copy it in blue because we already know that that's part of the formula. Okay. So A, which is 3x squared, times B, and B is 2y cubed, plus b to the square. And we just said that b is 2y cubed, and that should go to the square. Now, because of PEMDAS, where we simplify first our exponents, I'm going to solve first the exponents and do the power of the powers. This 2 will affect the x, will affect the 3, and this square will affect the y, and will affect the 2 as well. Okay, and then I'm going to multiply the 2, the 3, and the 2 from the middle term. Okay, so let's see. 3 to the square. How much is 3 to the square?
6x, 3.
No. How much is 3x?
9x.
9x
Okay, 9x to what power?
to the fourth power.
Power.
To the fourth power. Why it is 9 and not 6? Because it is not 3 times 2. It is 3 multiplied twice. Okay. And in here, since power of a power, we multiply the exponents. Okay. Minus 2 times 3. 2 times 3.
6.
6 times 2.
12.
12. And you can see that the variables are different. So we just copy them one next to the other in alphabetical order with whichever exponent it has. So we're going to say x to the square, because the x comes first, and then y to the cube. Okay. Plus, how much is 2 to the square?
4.
4. And y cubed to the square?
5.
y cubed to the square. Remember what we just said?
6
Because we multiply. And 3 times 2 is 6. And that is it. That will be my final answer. Now, right now, we're multiplying. Okay, we're going from one parenthesis to the square, and we find a trinomial. Once that we get to 8th grade, we're going to do it the other way around as well. I will give you the trinomial, and you will factor it out to get the parenthesis. Questions? Easy peasy, breezy, lemon squeezy, right? Okie dokie then. We're still missing one more formula of the squares, and hopefully we have time to see the part of the cubes, okay? Because we have 4 more formulas. At least I want to teach you 2 more besides the one that's missing of squares, okay? And for right now, we're not placing the topic's name. We're leaving it like that. We're gonna continue this topic in our next class, okay? Next week, finish with the squares, and we're gonna start practicing a little bit more. And then we're gonna have a classwork or homework. Questions about this? No? Okie dokie then. This is it for today.